So I'm in the Hibiya Park in Tokyo, and I have been recently thinking about large language models and iPS cells uh, invented and discovered by Yamanaka. And if you introduce 4 genes, the so-called Yamanaka factors, to a mature cell, then you can make the cell into an iPS cell, which would have the ability to divide and mature into any somatic cell. So this was a major discovery in biology. But interestingly, to date, nobody has understood the whole process of how this transformation happens. So the Yamanaka factors, the 4 genes, the control parameters, but we don't understand how the cell does the job. Now, with large language models, we are probably facing a similar situation. Systems like GPT-4, they are configured in such a way based on the transformer architecture, and we roughly know how reinforcement learning from human feedback would work to kind of fine-tune these networks and realize the capabilities that have astonished us. So in a general sense, we know, but we don't understand the details. And I suspect that cases like iPS cells and large language models like GPT-4, when we are facing truly interesting cases of emergence. Emergence is a very novel idea, and it has been around for quite a while. But only recently we are starting to see artificially induced cases of emergence. And by saying something emerged from something, we are probably admitting that we don't understand the whole details of it. We don't understand how iPS cells come to be. We don't understand how GPT-4 has acquired such incredible ability to pass the Turing test effectively. Well, there's some argument about it, but effectively passing the Turing test and effectively passing the false belief task and, affordance judgments and, Winograd schema challenge, all these feats. We don't understand how the large language models are doing that. So it's like a human child. You can educate your child. You can put the child into a school environment, learning environment. But at the end of the day, you don't actually know how the child would come out to be. And that's autonomy, that's emergence. So, given the fact that we don't understand the whole process, apart from really, really roughly configured parameter settings and so on, maybe we need a new science of emergence, in which we start from the assumption that probably we don't understand and we wouldn't understand everything, but we can probably work out roughly mapped out configurations for a system to have a certain set of capabilities. And that this would, of course, have a lot of implications for ethics and research directions and theoretical frameworks. And, I think it is very important to see the common features between iPS cells and GPT-4. And that is the thought I was having walking in Hibiya Park today. It's a sunny day in Tokyo. And there's a really wonderful specimen of bonsai here. It's a rather large bonsai tree, and there's a small pond here. So with bonsai, you can only have a rough idea while it will come out. But the biology would take care of the rest. So maybe with iPS and with large language models, we are entering a new era of science of emergence, technological emergence, and I think we need to do a lot of thinking before we arrive at optimum portfolio, if you like, of research, policy, and ethics, and so on. It's going to be a hot day today in Tokyo.